this video, we will discuss about final prices with a special discount in a shop. You are given an integer array prices where prices of I is the price of ith item in a shop. There is a special discount for items in the shop. If you buy the ith item, then you will receive a discount equivalent to prices of j, where j is the minimum index such that j is greater than I and prices of j is less than equals to prices of I. Otherwise, you will not receive any discount at all. Return an integer array answer where answer of I is the final price you will pay for the ith item of the shop considering the special discount. So what they are saying is that in the input we are given an integer array prices which denotes the price of the ith item in a shop. So now there can be some discount applied over some of the items, and how is that calculated? So what we need to do is basically that we need to find out that particular discount, and after that discount whatever will be the final price for each of the items, that we need to return as our answer. Right now, how do we find out the discount? So see, for any number, right, we will check towards its right, whichever is the first index where the price, right, is less than equals to this particular price, then that price will be the discount for this particular price. Basically, when I am considering 8, then I will start looking in these elements that which is the first index where the price is less than equals to 8, right? So I'll see that for 4 is less than equals to 8, right? So then that means 4 is the discount for this item. So 8 minus 4 will be 4. So the final price for this item will be 4, right? So that is what we need to do. First index, we need to select the minimum index, right? If this is I and the one I'm looking for is j, then I need to find the minimum index where prices of j is less than equals to prices of I, right? So if you will see here, for 8, we find out that 4 can be the discount. So 8 minus 4 would be 4. Then for 4, 6 cannot be because 6 is greater than 4, but 2 can be. 2 is less than equals to 4. So 4 minus 2 will be 2. Then for 6, can 2 be the answer? Yes, 2 is less than equals to 6. So 6 minus 2, 4, right? Then for 2, 3 cannot be, and there is no further element. So there will be no discount for this. It will remain 2 only. For 3 also we don't have anything, so it will also remain as 3 only. So this is what is needed to be returned as our answer, right? So now how are we going to solve this? So see, given the constraints of the problem that the maximum length of this prices array can be 500 only, right? So can we apply brute force over here? Can we think of an approach that is of n square? Yes. What should be that approach? So see, for each index, I want that after that index, which is the first index where the price is less than or equals to this particular index, right? So what I can do is that I can fix one of my pointers here, that is I, and I can start moving my j from I plus 1 till the n, right? And I can identify that at whichever point my prices of j becomes less than equals to prices of I, then that is the discount. I will just deduct prices of j from this and I will stop there for this particular index, right? So what we can do is that first we can create a vector, right? First we can create a vector named result, and we will make a copy of the prices. Why copy? Because in some of the cases when we won't be able to find any discount, for example for this 2 and 3, so these have to be copied as 2 and 3 only, right? So that is why we are making a copy of the prices. We could also modify the original array itself, but it's better if we do not modify the input. So both the ways it is possible. So what we will do is that we will run a for loop of I, right, starting from 0 till n, right? So first it will be fixed at index 0, then at 1, then at 2, and so on, right? And then inside this, we will try to find out the discounted price for the item at index I, right? So we will run another for loop of j starting from I plus 1 till n, right? And then we will check that if at any point the prices of j is less than equals to prices of I, right? Then that means the condition is satisfied, right? So what we will do in result at index I, we will subtract this discount, which is prices of j, right? And then we will break this loop, right? So this is what we can do. And at the end, we can return this result, right? So see, what are we doing here? First, we created a resultant array. So this will look like 8, 4, 6, 2, 3. What are the indexes? 0, 1, 2, 3, 4, right? So firstly, I is going from 0 till n, right? So initially I will be 0 and j will start from 1 till n, right? Now we will check prices of j, that is 4, less than equals to prices of I, that is 8. Condition is true. So in result, at index I, that is index 0, we will subtract prices of j, which is 4, right? So this will change to 4 and we will break our loop, right? So now I will start from 1 and j will start from 2, right? Now again, this will be 6 less than equals to 4. So is it? No. So j will become 3 now. Then 2 less than equals to 4. Yes, it is. So it will come inside. This will become 2 and we will break out of the loop. And now I will become 2 and j will start from 3 only, right? Now again, 2 less than equals to 6. Yes, it is. So we will subtract 2 from here. It will become 4 and we will break out of the loop. I will be 3 now. J will start from 4. Then 3 less than equals to 2. No, so j will become 5 and we will stop here because we have crossed n, right? So now I will become 4, j will start from 5, but 5 is out of the range, so we won't go further. And now I will also become 5. Now I is also out of the range, so we will stop here and our final array will be 4, 2, 4, 2, 3, right? So in this particular case, this is a loop running n times, right? This is the loop starting always from I plus 1. We can say that this is also running n times, right? So the time complexity of this code will be order of n square. And what will be the space complexity? So we have only taken this vector, which is our answer, right? So if you are considering the answer vector also as an additional space, then it would be order of n. Otherwise, you can consider it as order of 1. That is constant, right? Now, how do we optimize it? Can we think of an approach which is of linear time? Is it possible? Yes, it is. Now, how is that possible? Let's see. If I tell you that I have encountered some elements, right, and I am at a particular element, right? Now, this element can be the discounted price for these elements, right? Out of these, whichever have already been discounted for them, of course, this would not be the discount, but for the ones which are not already discounted and where this price is less than equals to that particular price, there this too can be the discounted price, right? So basically what I am saying is, so first I have an A, right? I don't know what is going to be in the future. I'll just keep it somewhere that I have encountered an A, right? And again, I will have a resultant array, which will be the copy of prices, right? And these will be its indices, right? Then I see that, okay, now I have a 4. Now this 4 can be a discounted price for some item. Now I see there was an item 8 which has not been discounted yet, right? So I will check, can this 4 be a discounted price for 8? Yes, because 4 is less than equals to 8, right? So now I will change this 8 to 4. Basically, I will do 8 minus 4, so it will become a 4, right? So now 8 has been discounted, so I can remove this. Now 4 is not yet discounted, so now I will keep 4 somewhere and I will move forward, right? So now I have a 6. Now I will see that the only item which is not yet discounted is 4. But this 4 cannot be discounted with 6. Why? Because 6 is greater than 4, right? So I cannot do anything. I will keep 6 also here and I will move forward. So now I have a 2. Now can this 2 be a discounted price for any of these? So I will check. 2 is less than equals to 6, right? So yes, for 6 it can be a discounted price. So I will do 6 minus 2, which will give me 4. So this will change to 4, right? And this is discounted now. And then if you see, we have a 4 also. So we'll check, can this 2 be a discounted price for 4? Yes, because 2 is less than equals to 4. So we'll do 4 minus 2, which will be 2. So this will be replaced with 2 and this will be removed, right? Now 2 is not yet discounted. Then we move to 3. Can this 3 be a discounted price for 2? No. So we will keep 3 here and then we move forward. Now we do not have any element, right? So then that means this is the only discounts that we can apply. And see, this is the answer that we wanted, right? So this thing where I was storing all the items where I haven't applied the discount yet. So this is nothing but a stack, right? This is nothing but a stack, and this problem becomes a version of the classic problem of finding out the next smaller element, right? Because see, for 8, we are finding out the next smaller element. Which is the next smaller element? 4, right? So, what we are doing is that whenever we are encountering any element, we are checking that whatever are the items present in the stack, can this 4 be a discounted price for that items or not, right? If it can be, then we will apply that discount here, right? And we will remove that item on which we have applied the discount from our stack, right? And another thing to keep in mind is that since storing these elements into the stack won't help us, right? Because we want to update the values in the resultant array. So we should know the index, right? So instead of the elements, we will store the index in the stack, right? So when you will store the index in the stack, you can just check that if the prices of j that you are considering right now, if this is less than equals to prices of whatever is your stack st dot top. With this we can compare, and if it comes out to be true, the condition comes out to be true, then what you can do in your result at the index st dot top, you will subtract it by prices of j, right? So this is what we can do. So let's quickly look at the code for the stack approach. So first of all, let's create a vector result for storing our answer, which will be the copy of prices vector, right? Then let's create a stack which will store an integer, and let's name it st, right? Then we will loop inside our prices vector. So for int j equals to 0, j less than prices dot size and j plus plus, right? Then inside this we will check that while our stack is not empty, right? While our stack is not empty and prices of j is less than equals to prices of st dot top, then that means this particular price, which is prices of j, can be a discounted price for the price at the index st dot top, right? So what we will do is in the resultant array at the index st dot top, we will subtract prices of j, right? And then we will pop this from our stack because this item has now been discounted, right? And at each point, we will also be pushing the current price into the stack, right? So we will store its index in the stack, which is j, right? And at the end, we can just return our result, right? So let's run this. So here we are running a for loop which is going from 0 till n, right? This is running n times. Now inside this, there is a while loop where we are accessing and removing elements from the stack, and we are pushing the elements also onto the stack. But a particular element will be pushed and popped from our stack only once, right? So we can say that the time complexity of this approach will be order of 2n, right? Which can be written as order of n because 2 is a constant over here, right? Coming towards the space complexity, so we have taken a stack over here, and in the stack, in the worst case, we can have all the elements of the prices vector, right? So the space complexity will be order of n, right? So let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.